Michael, do we have any questions that our viewers have sent in?
I sure do. This one is a nice geometry question. It's one that I struggle with on a regular basis. In a quadrilateral PQRS below, the sides PS and QR are parallel for what value? Gives you for what value of x? So it gives you 70 degrees is the P corner, 112 degrees is the S corner, and x is the Q corner.
I can take that one. So I actually just copied that onto my computer really quick because these questions are really helpful to have drawn out. Also, yeah, you really want to be able to mark these. So if you get this problem and your teacher does not give you, like your teacher puts it on the board or something, where you can't really kind of draw on it, I would suggest that you just redraw it yourself because it makes a huge difference. Let me see if I can make this a little bit bigger. That's possible. Oh, that's really big. All right, that'll work. So yeah, if you look at my screen, I just copied it there, so we have it all on the screen. Let's see what we have here. In quadrilateral, PQRS below, or in this case to the right, sides PS and QR are parallel for what value of x? So here is kind of what we need to know. I'm assuming that you have recently learned about the parallel lines conjectures. So I'm going to quickly draw that out. So anytime we have parallel lines that are cut by what's called a transversal, so something like this, where these lines are marked as parallel. I want to emphasize that they're marked as parallel because one big thing in geometry is you're not making assumptions. When we have this relationship where these lines are cut by a transversal, I'll just write that up here, I guess really tiny. That line that's cutting is called a transversal. We have some relationships in all these angles. So we have what are called corresponding angles, like here and here. These are always going to be congruent. We also have alternate interior angles that I'm going to do in this color, blue. These are also always congruent. I'll just kind of highlight these. And then we have alternate exterior angles that I'll do up here in green. Looks really dark. And if you guessed it, these are also congruent. So we've got these relationships. So the conjecture with this, I'm not going to write it down. I'm assuming that you are kind of familiar with this, would be that if you have two parallel lines that are cut by a transversal, all of these relationships will be congruent. So corresponding angles, alternate interior angles, and alternate exterior angles. The flip of that is if any of these relationships exist, so if corresponding angles are congruent, or if alternate interior angles are congruent, or if alternate exterior angles are congruent, then the lines that are drawn there are parallel lines. So we can kind of flip that conjecture around. I want to emphasize the word or there because if any one of these are conditions are met, then you have parallel lines. So where does that bring us to for this problem? Well, what we want is PS right here and QR to be parallel for what value of x? So I don't know, these tend to throw students off because it looks different. When you look at this example, you see this transversal and these parallel lines that extend infinitely. When you look at this figure, which it's a quadrilateral, it looks kind of like a parallelogram, but it may not be. It doesn't extend forever, and so a lot of times students don't really relate this to this. But keep in mind, this relationship still exists whether these lines extend forever or not. So what I like to do at first is I just extend these lines that I want to be parallel. It kind of makes it more, let's see if I can move this. It kind of makes it more similar to what you've been looking at, which is always, nope, I can't move that, so I'm gonna have to redraw it. Which is always helpful because if you're more familiar with it, let me just extend that like that. if you're more familiar with this kind of figure, then it makes it easier to kind of relate what we were talking about. Now, we also want to extend the transversal we care about. So you notice that there is, you can consider this a transversal right here. It's cutting through those two parallel lines. This yellow one is kind of doing the same thing, and we could extend these further if we wanted to also. So I'm going to do that in a second. But what we want to think about here is which transversal do we care about? And this is also something that can be a little tricky at first. We only really care about one of them. So I'm going to extend this one because this is the one that's attached to this X angle that we're looking for, angle Q. So once we do that, then we can kind of think about this relationship. And if you imagine this is kind of turned sideways, it's the exact same thing. Two parallel lines cut by one other line, the transversal. So we need to kind of see this relationship. Well, 70 degrees, this angle and this angle, they don't meet the alternate interior corresponding or alternate exterior. And there is one more relationship called same side interior, but I'm not going to get into that right now. Because this is one of the things, if you remember this concept really well and you forget this other concept, then you can work it out. So for angle X here, we would think, what is related to angle X right here that I know based on those parallel lines? Well, I would actually look over here and say, oh, this one's inside. The alternate interior is also inside. So for these to be parallel, this right here needs to be congruent to this right here. So really what we're looking for is this angle. If I know this angle right here, then I also know this angle. So it brings us to another conjecture. There's just so many of these in geometry. So let me sketch this really quick. If you look at this right here, and I'm kind of redrawing this portion over down on the bottom of my screen to look at that. Let me get rid of that, it's not messy. All we're going to do is think, what is the relationship between these two angles? So I've got a 70-degree angle right here, and I'll highlight this in yellow so you can kind of see what I'm looking at right here is the same thing as right here. So if you think about this, these angles are not equal. First of all, they don't look equal. But second of all, there are two angles that are formed from one line. So if you think about the measurement of a straight line, this would be 180 degrees. So these two angles right here have to add up to 180. So what we're really asking is, I'm going to throw a variable in there, z. What we're saying is that angle 70 degrees plus this angle z should add up to 180. And then we solve for z and we get 110 degrees, which is this angle right here. Now that we know that, we also know angle x is 110 degrees. So it's kind of a long process when I explain it, but if you know these relationships really well, you could quickly sketch those parallel lines by extending them. Extend that transversal that's most related to the angle you're looking for, and you can just kind of eyeball it. Like, I drew out a lot more than I would have if I were actually solving this, and my students who are really comfortable with this, a lot of them can just get it really quick because they can visualize it. And I think that's, I don't know, geometry, that's always the hardest thing with these figures, is visualizing and being able to pull out the important information out of sometimes like crazy looking figure.
Yeah, I always had trouble with the conjectures
Right.
and keeping those straight and knowing, well, what is it that I'm supposed to use on this one, or what is it?
Or are these supposed to be equal, or are they
Yeah.
supposed to add up to 180? There are
Yeah.
a lot of them, so I don't know. Make flashcards, take good notes.
Is there a good book that just has, or like something that just, or a cheat sheet or something that just has a list of all of them
Yeah.
that students could maybe refer to? Not just a geometry textbook, but do you know of something?
So I mean, I'm sure there are some like cheat sheets that you could probably buy on Amazon or somewhere like that. I generally have my students.
Geometry for dummies.
Yeah. I generally have my students make one as we go, and I just, as they're going, it's, here's the next one, and you know, it can span 8 chapters of geometry, but they can quickly look back and be like, God, I recognize this, and I recognize it from 2 months ago, and just flip back really quick. Because I think also writing them out themselves helps
Yeah.
to retain a lot of that.
That is really true.
So
Those conjectures, man.
there's a lot of them, though. I think we have like 60 or 70 of them in one semester of geometry. It's just,
One semester.
Yeah.
That's not even.
yeah.